Programming is a field that requires memory and creativity. Reading and understanding source code written by others is based on memory, and creating new source code is also based on creativity. According to these two premises, memory and creativity, we can realize things that enrich our lives based on programming. Programmers can be said to be experts in memory and creativity. In most cases, it is excellent at reading tens of thousands of lines of source code and adapting it functionally. Even writing a single source code requires multiple layers of knowledge. What are variables? What are functions? What is object-oriented methodology? What is MVC model? What is design pattern? Clean code. If we look at how all of this knowledge is learned and achieved based on education and cognitive science research results, we can find out how to teach and learn programming. It will become possible. Purugirimo Inoue is a book that discusses research topics in science. Programming is a field of great processing of cognition and is also a subject of study by educational science. By dividing the psychological and physical factors that make programming possible, we can find the optimal way to read source code, and we can also think about ways to impart courage and confidence to new employees with relatively less industry experience at a company. There will be inevitably experiencing cognitive load during the program writing process is not an obstacle, but rather opens up experience in challenging fields. If the cause of the cognitive load experienced in reality is well known, systematic supplementation is possible. Cognitive scientific examination of the practice of code and writing as a way to solve problems will enable not only individual practice but also collaboration and large-scale design, and will also reveal effective practices to support new developers. Knowing how the brain works meant understanding problem-solving and learning expertise. If you learned programming in a computer science department, learning to look at it from a cognitive scientific perspective is also a challenge and an extension of familiar scientific observations. When solving problems and writing programs through concretive abstraction, which requires a great deal of attention, when correcting source codes and debugging errors, the purpose of this book is to first help you understand how the brain processes of these works. If you understand well what the code presents to the brain will respond better, and you will be able to implement it well. It is not only personal, but also team collaboration, and is also part of the business of training new employees at a company. The example of the approaches in this book is these. The first type of difficulty, lack of knowledge, no exposure to the programming language itself. Second type of difficulty, lack of information, no exposure to the functions provided by the programming language. Third type of difficulty, lack of processing handling, less experience in memory with no basis for decoding information. These three types of difficulties are related to memory mechanisms, and it can be said that an educational perspective of scientific approach to programming teaching is very meaningful in that once it is formalized, it becomes possible to create and test solutions. This book consistently deals with the cognitive processes that affect coding. It is cognitive, scientific, and educational. If you have interdisciplinary intellectual curiosity, obtain it and read it. It will be possible to learn about the achievements of adjacent studies on coding and to actually reflect them in work.